Right, hello and welcome to our taster video and our virtual induction for further mathematics. In this video, I'm going to give you some information about the further mathematics course and a taster lesson of one of the most important topics in further mathematics. Now, as you are applying for further mathematics, you're obviously also applying for mathematics as well. So what I would suggest is that before watching this video, ensure you have watched the mathematics video as well. So, some introductions. Meet the team. So these are the teachers who could be teaching you in September if you join us at Herts and Essex. So I am speaking right now. This is me. I am Mr. Corner, and I am the subject leader for the sixth form element of mathematics and further mathematics. This is Ms. Watson, who is a very experienced teacher of mathematics and further mathematics as well. And our final teacher for next year on the further maths course in year 12 will be Mr. Fafalios, who is joining us in September, so I do not have a picture of him. So these are the three teachers who you will be having in September if you decide to join us at Herts and Essex. So before we move any further, we are going to hear from some of our current and former students about their experience of further mathematics at Herts and Essex.
I'd enjoyed it at GCSE, and I also knew that I wanted to study a STEM subject at university.
Further maths was my fourth option in year 13. I didn't actually need it for the courses I was intending on doing, but I just loved it.
It definitely was one of the most challenging things that I've ever done, but I didn't do many difficult things before that, so it was definitely worth doing.
If you're good at maths, do further maths.
Whilst I wasn't quite sure what I wanted to do in terms of university education, I knew that it would require that I showed the universities I was applying to that I had a good solid base.
The content range, especially including further maths, is incredibly expansive, and it can allow you to apply your skills to a wide range of situations.
I also did chemistry at A-level and physics at AS, and they had a lot of maths involved with them, so doing maths and further maths really helped with all of my A-levels. Doing further maths and enjoying it so much was the main reason I decided to choose maths for my degree.
For those of you that want to do further maths, the course is split the same on the further maths side as well. You also do further statistics, further mechanics and further pure, so it's essentially everything that you learn in your normal A-level maths with extra put on top.
I can say that I highly recommend taking further maths as opposed to just maths. It's just more interesting, the problems are better, the maths is more engaging because it is more challenging.
When I went to the open day and the induction day at Herts and Essex, the whole maths department was so welcoming and friendly, and they were really encouraging people who had a strong passion for maths to not only take maths but further maths as well, and I'm so happy that I decided to take it.
Upon doing research into many sixth forms, Herts and Essex stood out most in terms of its excellent maths department.
The teaching in the maths department is excellent, and although I worked really hard, I don't think I would have been able to get an A-star in both maths and further maths if it hadn't been for Mr. Corner and Miss Watson. They always went above and beyond to make sure we understood all of the content, and it meant we could get the best grades possible.
They really pushed us all to do our best, but they were also extremely patient.
They took so much time to make sure that I understood all of the topics. I just couldn't have done it without them, and I ended up coming out with a grade that I'm really proud of.
Other than academically, my favourite part of the class was definitely how tight-knit we were. There was only 9 or 10 of us that year, and it definitely meant that everyone knew each other very well. It was a really good atmosphere in class. Working hard but also having a bit of a laugh.
My whole further maths class was so supportive and really loved maths as well, so it just made such a nice environment to learn in.
My favourite parts of the course were probably the core modules, but also I really enjoyed in further maths the camaraderie we had in the small group.
Some particular standouts for me include learning how to manipulate with complex numbers, learning to factorise quartic graphs, and applying your skills to the real world in the mechanics topic.
Some of the things that I've really enjoyed studying in further maths was geometric series, a lot of the algebra stuff, and I also enjoyed being able to do different topics like stats, for example, which I still use, to this day.
Academically, my favourite part of the course was that we were able to do quite a varied choice of modules. This allowed us to, be varied while still having the kind of depth required, but it gave you a good way of keeping your options open. Like I said, I didn't really know what I wanted to do post sixth form, so if that was an engineering sort of side, then that would be more suited to the mechanics modules, and then if I was doing something more economics based perhaps, then that would be something more to do with the statistics modules.
The logical and analytical skills you gain from studying maths at this level have helped me on a daily basis in my degree.
I'm studying chemistry at university, and some of my peers who only studied normal maths at A level, they almost seem a little bit further behind than me because they didn't have the opportunity to apply the key concepts, like your calculus and your log laws and stuff like that. They weren't able to apply it as much as I was, because obviously I had a whole extra A level in it.
After Herts and Essex, I went to UCL and studied this degree called Management Science, which is an interdisciplinary course where you have to learn a number of different subjects at a pretty high level. And then after that, I actually became a solutions engineer for a software company called Tableau, which is a data visualization tool, and now that is currently owned by Salesforce. So I still use maths and further maths to this day, so don't think you stop using it once you go to work. You definitely carry on using it.
I went on after a gap year to study economics and management. Being able to have those statistical methods from doing the S1 and S2 modules were really, really useful. So when it has come to university, there's a lot of expectation on students. The workload under further maths and the way that the course is designed means that this really prepares you in a way that not many A levels prepare you for university study.
I did maths at the University of Leeds, where I've just finished my degree. Doing maths and further maths in particular helped me with my degree so much, as particularly in first year, a lot of the people in my course hadn't done further maths, so I really felt like I had a head start, and it just made the transition from A level to uni a lot easier.
Maths is obviously very helpful for me doing a maths degree, but particularly further maths helped bridge the gap between school and university. Students take all the opportunities that are given to you, if that's summer schools, conferences, and to try and enjoy it.
The maths department here at Herts and Essex does an incredible job at ensuring that you keep up to date with all the content taught throughout the year and ensuring that you do not fall behind. However, it is still incredibly important that you continue to work at home to ensure that you really consolidate everything you learn in lesson time. Herts and Essex will not let you down if you choose to study at the school.
I'm really glad that I did keep going with the A level and I didn't give up.
When you arrive here, it's really good to kind of get to know the class. That will happen organically anyway, but it was definitely a case in our year that helping out one another was particularly useful for us.
If you really enjoy maths and you're good at maths, I can't recommend doing further maths enough, and especially at Herts and Essex.
So I would really recommend studying further maths. Sounds scary, but don't worry, it's not that bad.
I always say that the difference between maths and further maths is that in maths, apart from like harder topics, in maths they walk you through the problem with steps A to F. In further maths, you need to find those steps by yourself, and in uni that's the kind of thinking they expect and want, so it sets you up so well for later. It develops your problem solving to a much higher level, and not only this, throughout the entire A level you are so well supported by the staff.
If this is something you're interested in, I think it's definitely worth pursuing it, especially at a school like Herts and Essex where the teaching is of such a high standard. So yeah, best of luck in what you choose to do after GCSEs, and I hope you do consider Herts and Essex. Okay.
Right, so I hope you enjoyed hearing from our students and that opinions and advice really helped you to make informed decisions about studying further mathematics. So we're just going to summarise some of the things that were said there. So you should study further maths if you're on track to achieve at least a grade 8 at GCSE maths. That is our entry criteria for the subject, at least an 8. if you want to study maths in more depth than you would in just doing a single A-level, and you really are keen to develop your skills and expertise in maths, I'd suggest you study further maths. You really enjoy the challenge of mathematics, and you really do want to study it to a highly advanced level. Obviously, studying further maths, you will be doing topics in much more depth, new content, and really pushing your skills and knowledge to higher levels. We offer so many enrichment opportunities alongside further maths, such as participation in individual math challenges, team maths challenges up at the University of Cambridge, participation in mathematical Olympiads, attending problem solving conferences. The opportunities are endless if you want to really engage yourself with an interest in maths. If you study A-level further mathematics, you will achieve 4 A-levels, but only study 3 subjects. You will get maths, further maths, and 2 others. Now, what most people will say to you from past students is they don't feel like they're studying 4 subjects. They feel like they're just doing maths and 2 other subjects. The links between maths and further maths are obviously really strong, and so you will not feel like you're doing 4 separate subjects. So it just feels like you're doing 3, but you'll end up with 4 A-levels, which is obviously fantastic. Now, if you think you might in the future be interested in a mathematics degree at university, do not worry if you've not formed any of the decisions yet. But if you think you might, studying further maths will really help your chances of getting into university. The number of universities requiring further maths A-levels to have been studied to be accepted into a maths degree course is increasing all the time. So if you think you might want to do maths at university, it really is worth studying further maths. And it can even lead to a lower offer if you study further maths. It could, instead of being like A star, A star, A, it could be A star, AA if you study further maths. Often that is the thing. Further mathematics is seen as a facilitating subject for many Russell Group universities for the courses listed there. All those degrees could include some mathematical content. So studying further maths would be of benefit to you if you wanted to pursue any of those degrees. Studying further maths opens the door for many degrees and careers in the future as well, as you will see on the next slide when I talk about what our alumni have gone on to do. If you join us at Herts and Essex, you will have fantastic chances to succeed in further maths. Last summer, all our further maths students got an A star and A in their maths A-level, and 77% got an A star and A in their further mathematics A-level, which is really high results and results we are really proud of. Now, here's the destinations of some of our recent alumni from the past 3 or 4 years. You can see there they have all gone on to Russell Group universities, really high level. And yes, naturally, some of them have gone on to study maths, but you can see that studying further maths does not mean you just have to want to study maths at university. We've got people doing joint honours, we've got people doing sciences like chemistry and physics, engineering, economics. So it really does open so many doors to you studying further maths. And for those that have now graduated, we have former students in careers in finance, engineering, business, medicine, technology, accountancy, statistics, and teaching. So having an A-level in further maths can provide you with so many opportunities in the future. So here are some of the skills you will gain and develop from studying A-level further mathematics. Naturally, you'll be looking at solving quite challenging problems, and so your problem solving skills will really develop there. You will learn how to structure and work really logically to present your solutions. Following algorithms and processes, you will develop these, and all of these are really transferable skills that you can use in a degree, in a career, not just mathematically, but in a wide array of circumstances. You will learn how to analyze and reason logically. You'll be working on spotting patterns and making links. We'll model mathematically. Now, this is a really, really key concept, and that will be looking at real world concepts and trying to adapt and criticize models to work with them. You'll be working on factual recall, like learning and applying. Statistical fluency is really key here. We'll be looking at developing statistical models and using them to analyze and interpret data, and then adapting and criticizing models because of it, and statistics comes up in several jobs. We use a lot of technology in further maths. We use an updated version of the calculator, which can do a lot more, and you'll be using that a lot. We also do quite a bit of computer work and graphing as well. And I have already mentioned data analysis and interpretation. All of those are transferable skills to maths degrees, other degrees, and careers later on. So here's a bit of an overview of the course. If you study further mathematics, you will have 18 lessons of maths across the fortnight. You'll be in your own class with just other further mathematics students, and you'll have 6 lessons of each teacher. Your timetable will have half lessons saying maths, half lessons saying further maths, but we treat any lesson, you could be taught maths or you could be taught further maths. Okay, now in year 12, you'll mainly be studying maths. Probably 3/4 of the content you're studying in year 12 will be maths, and 1/4 will be further maths. So the only further maths content you'll come across in year 12 will be the further pure year 1. For the maths, you'll do the pure year 1, the stats year 1 and year 2, and the mechanics year 1 and year 2. And then in year 13, it kind of switches. You'll just do 1/4 maths and 3/4 further maths. So you'll do the pure year 2 content for the maths, and for further maths, you'll do further pure year 2, further stats 1, and further mechanics 1. Okay, so if we look at further maths in more detail, so you can see there's further pure year 1, further pure year 2, further stats 1, further mechanics 1. There are 4 1-hour 30 exams at the end of year 13, each 25%. 2 for further pure, which would mix up the further pure 1 and further pure year 2, 1 for further stats, and 1 for further mechanics. Okay, now the topics you'll study in the further pure build on some of the stuff you're doing, the maths A level, but there's so many concepts you'll meet here that you wouldn't meet if you didn't study further maths. Things like matrices and complex numbers, polar coordinates, differential equations, hyperbolics, volumes of revolution, they are unique to further maths. But then we've got like proof, series, and vectors, and roots of polynomials, which also come up in maths. Don't worry if loads of those concepts don't mean anything to you at the moment. They're all things you will meet. Okay. Further stats, we build on the concepts you learn in the stats part of the maths A level. So we'll look at things like discrete random variables, more distributions, Poisson geometric negative binomial on top of the binomial and normal from the maths A level. We look at more hypothesis testing, central limit theorem, a chi-squared test, and a probability generating function. Again, don't worry if those don't mean much to you. And in the further mechanics, we build on the mechanics A level by looking at momentum and impulse, work energy and power, elastic strings and springs, and elastic collisions. Okay, again, please don't worry, this will all be met in year 13. Okay, we also provide a lot of support for those looking to study mathematics at top universities, which require admission tests. So some of the top universities like Oxbridge or Russell Group will require an extra thing on top of the A-level, such as the STEP paper for Cambridge, the MAP paper for Oxford, or the Test of Mathematics University Admission, the TMUA, for other leading Russell Group universities. And throughout, sort of towards the middle of year 12 and throughout year 13, we do a lot of work with you to help you get there if that is something that you're interested in. But don't worry if you haven't made that decision yet, that will all come. Okay, so we have now reached the point of this video where we're going to look at our induction lesson. So I hope you're ready. Right, so we're going to begin our lesson, which is going to start by introducing you to one of the most important topics in further maths, one of the first topics you meet, which is complex numbers. To start with, there are 10 questions on the screen. I want you to see if you can write down 2 examples of the following. Just jot them down. If there's anything you don't understand, just leave it blank. Don't panic. You might not have heard this definition before. It's nothing to worry about. Just leave it and we'll go through it in a minute. So pause the video, write down some answers. Okay, so I'm going to go through some of the definitions before I now give you the answers. So a natural number is those used for counting. So like 1, 2, 3, 4. There's a debate whether 0 is natural between some mathematicians, which is why I put it in brackets. But they're the first numbers you will have learnt as a very small child when you first learned how to count. Now that's n with the double slashed on the diagonal is used to represent natural numbers. Integers, you should know what integers are. They are whole numbers. So they are positive or negative. Think when you were younger, you probably, once you've learned about 1, 2, 3, 4, you probably started to learn about -1, -2, -3, -4, probably in the context of temperature. Number without a fractional component, basically, a whole number. Z with a double slash for the integers. Rational numbers a number that can be expressed as a ratio of integers, i.e. a fraction. Q, with that line down the middle, represents rational numbers. So that's things like a half, 3/4, a third, 5.8, decimals, because decimals we can turn into fractions. Irrational numbers is a number that can't be expressed as a ratio of integers, and that's Q dash. Think back to set notation and Venn diagrams, that means not Q. Yeah, so that's why it's irrational. The most famous irrational number is probably pi, but also like surds, like √2, √5, they are irrational. And then some of you might be thinking of the number e if you've heard of e. The real number is any number that can go anywhere on a number line, like a simple number line, 1D number line, okay? Which is actually all of the above, because natural numbers, 1, 2, 3, 4, they go on a number line. Integers, -2, they go on a number line. Rational numbers, like fractions, like a third, has a place on the number line. A quarter has a place on the number line. Irrational numbers, pi has a place on the number line. √6 has a place on the number line, okay? So these are some possible answers you could have had for these. So natural numbers, just some positive integers. Same for number 2. Negative integers, very straightforward. Integers could be positive or negative. Rational numbers which aren't natural, so that means they have to have a denominator that's not 1. Rational numbers which are also integers must have a denominator of 1. There's some irrational numbers. There's some real numbers. You can have anything. Real numbers which are natural, integers, and rational. So natural is the most restricting thing there, so they have to be positive integers. And the gap between set z and set n is negative numbers. Okay, now this gives us kind of a hierarchy of numbers, where natural numbers is the most restricting, but natural numbers are also integers. Integers are also rational, and rational are also real numbers, which is why I've got this Venn diagram stacked inside itself, because the natural number is all of the above. So your task is to try and place these numbers in the correct place in the Venn diagram. So make a copy of it and try and put those numbers in the right place, and I'll give you the answers when you're done. So pause now. Right, here are the answers. So 5 is clearly a natural number. 15/3 is also natural because it is 5. Some of you might put it in Q because it was a fraction, but it is 5. Now, if it was like 14/3, that's not a whole number, so that would go in Q. √4 is 2, so it's natural. Now, some of you might put it in Z because you could have thought it was 2 or -2. And don't worry too much if you've done that. Now, we tend to, mathematically, √4, we take the positive root, it is 2. You only need to worry about taking a positive root or a negative root when you're solving an equation. So x squared is 4, gives you x is 2 or x is -2, but √4 is just 2. So z, the integer, is -3. Q, the rational numbers, -2/3 is a fraction. 5.2, we can make a fraction. And remember, recurring decimals you can turn into fractions, like 0.33 you should know is a third. 0.272727 is actually 27/99. And the real numbers, what's left is pi and √5. So the real numbers, okay? Now, the word real has come up quite a lot this morning. When we've been looking at the quadratic formula, it also comes up. You might have heard of the terms 2 real roots, 2 equal roots, or no real roots, which comes from the discriminant. b² - 4ac is called the discriminant. This bit is building on knowledge you do right at the start of the maths course rather than the third maths course, when we looked at we're looking at a lot of detail in maths at quadratics. So don't worry if this is, I'm using terminology you don't understand, because you do this before you did this topic anyway. So the discriminant is b² - 4ac. And that tells us how many roots we get. 2 real roots, your quadratic cuts the x-axis twice. 2 equal roots, your quadratic touches the x-axis once. No real roots, the quadratic never crosses the x-axis. Now this one occurs, the first one, if you've got a positive discriminant. This one occurs if you've got 0 discriminant. And this one occurs if you've got negative discriminant. Now, if you've got negative discriminant, remember in the quadratic formula, it's the square root of b² - 4ac. So if b² - 4ac is negative, you can't square root it, and your calculator tells you it's a math error. Okay? So that's why we get no real root. But, so we need to introduce what we do when we square root negative numbers. Now, this is a definition of an imaginary number, which some of you might have heard of. The square root of -1 is termed to be I, such that I squared is -1. Okay? Very important definition, I. This gives us imaginary numbers. AI, where A is the coefficient of I, like -5i, √3i, they're imaginary numbers. Now, A is a real number. This symbol here means A belongs to the set of real numbers. We could also get complex numbers, A plus BI, where A and B are both real, such as 2 - 3i. 2 is the real part there, -3 is the imaginary part. minus a half plus 3 root 2i, minus a half is the real part, 3 root 2 is the imaginary part. Okay, now every number you've met in your life is actually a complex number. I hope that blows your mind. Number like 5 is 5 plus 0i, root 2 is root 2 plus 0i, pi is pi plus 0i. So every number does have that real part and that imaginary part, but you just don't need it with working every day. So this gives us a new Venn diagram with complex numbers on as well, which I just love. It's such a fabulous diagram, which I really enjoy. Anyway, let's look more at imaginary numbers. Okay, so write the following in terms of I. So the square root of negative 36. Now using third laws, that's root minus 1 times root 36. Root minus 1 we've just learned is I. Root 36 we know is 6, so that's 6i. Now, in general, you can go straight from root minus 36 to 6i without doing these intermediate working. I'm just showing you how it works with the third laws. Root minus 28, split up as root 28 times root minus 1. Use third laws on root 28, which is 2 root 7. So you get 2 root 7 times I, which is 2 root 7i. Okay, now here are 5 for you to have a go at. So pause now and 2 of these, and I'll give you the answers when you're done. So root minus 4 is just 2i. Root minus 32 is 4 root 2i. Root minus 100 is 10i. Root minus 45 is 3 root 5i. Root minus 98 is 7 root 2i. Do not forget 49 is a square number there. Okay, right. Adding and subtracting complex numbers is really straightforward. It's just like simplifying algebra. Okay, all you need to do is add the imaginary part and add the real part. So on the first one, z1 plus z2, we're going to add the minus 1 and the 4 to give 3, and do the 3, add the minus 5 to get 2. So your final answer is 3 minus 2i, z2 minus z3. So 4 minus minus 6 is 10, minus 5 minus minus 3 is, sorry, 5 minus 5 minus minus 2 is minus 3. So our final answer will be 10 minus 3i. And then z3 minus z1, so minus 6 minus minus 1 is minus 5, and minus 2 minus 3 is minus 5. So we'll get minus 5 minus 5i. Very simple. It's just like adding, subtracting with algebra and collecting like terms. Just be careful with negatives. So here are some questions which you can have a go at. You don't need to do them all. Definitely do the ones in red at the bottom, and do as many of the ones as say question 2 as you like. Pause it now and have a go. So here are the answers to the ones in question 2, and there is my working for the other ones as well. And the final part of this lesson is going to be about solving equations. So we're going to solve equations either by completing the square or by the quadratic formula. So we can do the first one by completing the square. So z squared minus 10z plus 26 is 0. I'm at z minus 5 squared minus 25 plus 26. That's completing the square, which you should know from GCSE, is 0. So z minus 5 squared plus 1, simplifying, is 0. Take it onto the other side. So z minus 5 squared is minus 1. Now you can square root both sides. The square root of minus 1, remember we're solving an equation, we want 2 answers, we'll get plus or minus I. So z minus 5 is plus minus I, so z is 5 plus or minus I, taking the 5 onto the other side. And the second one we're going to do by the quadratic formula. So you've got 2x squared plus 4x plus 5 is 0, so a is 2, b is 4, c is 5. Substitute those things into the quadratic formula. So I've got minus 4 plus or minus the square root of 4 squared minus 4 times 2 times 5 all over 4. That simplifies to root minus 24. Now use third laws on the root minus 24. You get 2 root 6i, and then just tidy it up at the end. So minus 4 over 4 is minus 1. 2 over 4 is a half. So I get minus 1 plus a half root 6i. So when you're solving equations, remember you'll get 2 answers. Don't forget your positive or negative root. You can either complete the square or you can use the formula. It doesn't matter. Okay. So here are 6, which you can have a go at. So pause it now and try 2 will be enough for you to do, and off you go. Pause it now. So here are the answers on the last slide. The last one was actually a trick question because it actually had real roots, not complex roots, and they're the 6 answers. So that reaches us to the end of our lesson. I hope you've enjoyed that, and if you've got any questions, you can get in touch with us via email. There's also a Google form for you to fill out with any feedback, any questions. If you've got any question about the lesson, about the course content, anything I've said, please get in touch. I really hope to see you in September, and have a good summer. Goodbye.